And welcome back. We are now going to go ahead and examine a new piece of code that's going to help us with our try catches, and that is the finally block. So the reason why we want to address this new block code is because there's a pitfall that we have if we want to do things like nesting try catch blocks. And while this new technique that we're going to learn today doesn't necessarily solve everything, it is just one more way to help assure against these potential issues. So for example, if we place a try block and the following catch blocks inside a larger try block or inside a larger catch block, this is where we can run into this first pitfall. On rare occasions, this is useful, having things nested, but it's almost always better to do this through a method definition and place the invocation of the method in the outer try or catch block, or maybe you can just find a way to eliminate one or more catch blocks or the try blocks completely, because there might be a better way for you to have your code. So when we start talking about these nested try blocks, if you place a try block and its following catch blocks inside of that larger catch block, we're going to need different names for those catch block parameters for the inner and outer blocks, because otherwise it's going to wonder which one are you specifically referring to. If you have, for example, to exception E, well, which exception E are you talking about? And this how it handles from Java, right? Java's like, hey, how do I handle these blocks? Oh, I'm going to look at the names of them. Well, if you place a try block and its following catch blocks inside of a larger try block, and an exception is thrown in the inner try block, but it's not caught in the inner catch blocks, then the exception is thrown to the outer try block for processing, and it might get caught in one of those catch blocks. So how do we help address this in a better manner? Well, we bring in what is known as the finally block. The finally block contains code to be executed whether or not an exception is thrown within a try block. This is also a great way for us to continue with program execution should, we get a catch block and what do we want it to do? Or we want something to happen regardless, right? The finally block, if used, is placed after a try block and its following catch blocks. The general syntax would be as follows. We have a try block, we have some catch blocks, and then we would have a finally, which then has whatever code you want to be executed when that exception is either thrown or caught. So this makes for a combination known as the try catch finally. If those try catch finally blocks are inside of a method definition, the way you think about this, every set of try catch blocks is inside of a method if you really want to think about it, even if it's the main method. All right, because the main method is a method, it's a special method that Java uses to differentiate where the program is executing from. There are three possibilities, therefore, that come from when we have the try catch finally blocks and they're executed. So we look at those possibilities. The first one, of course, is that the try block is going to run to the end and no exceptions thrown, just normal execution. In this case, the finally block is going to be executed after our try block has been executed. An exception is thrown would be our second scenario, right? So we throw an exception in that try block, it's caught in one of our catch blocks, and in this case, the finally block then is executed after the catch block has finished its execution. In the third scenario, an exception is thrown in the try block, but there's no matching catch block in the method to catch that exception. In this case, the method invocation is going to end, and the exception object is thrown to the enclosing method. However, one thing to note with the finally is that it's still going to execute that before the method ends. Now, note, you cannot account for this last case simply by placing code after the catch blocks. You can't just say, I could put code here. No, unless you have the word finally there, it's not going to actually be wrapped in there with this try catch. And let's just look at a real quick, simple example of how this works. So in here, I have an array of size 4. I have a try block that's going to attempt to get a value from that array, but notice it's saying array 4. If you remember how arrays work, they start at 0, which means the maximum value in this array of size 4 would be array of size index 3. So it would, of course, throw an error here, because if we try to simply just print out the statement, we're never going to reach that because it's going to get to here and throw an error, and that error is the array out of bounds exception, and all that's going to do is catch it and throw it into this print line statement, and then you notice we have a finally here, and then of course we have just code that exists outside of that finally block. So let's just go ahead and run this real quick, and you can see we get exception caught in the catch block, inside finally block, outside the try catch finally, and that's how it works. Now, if I were to change this, for example, to, let's just go ahead and make this 3. And I'm just going to make sure that I have a value in here real quick. So I'll just set int 3 of 3 equal to, let's just say 3, just so we have, again, a value here. Not int. I want that to be array. Thank you. And we go ahead and rerun this. We now get the inside try block. So it's now hitting this try block, skipping over the catch block, outputting the finally block, and then of course outputting the code that's outside of that try catch finally. So it's a pretty straightforward way of how this works. Again, the biggest thing to keep in mind is that this will still execute if for some reason that third scenario happens. You'll still have some code execution if it were to exit out of that method.